Okay, welcome back. Right now we'll focus on some other conversions and just get practice in setting this, in setting up these conversions and doing it the right way. Now, I should mention, maybe I did in the last video, maybe I didn't, but if there are other ways to do this. Okay, you might have learned other methods. However, with the complexity of some of the conversions that you are going to have to use this year, or you're going to have to do this year, it is best to try and follow my way. I'm not saying that because I think that all the other ways are wrong. I really don't. But I know what's coming later on, and I know that if you learn this way, everything will be easier for you, I promise. Okay, so let's take a look at number one, convert 1 centigram to grams. So you're probably thinking, well, what the heck's a centigram? Remember, we just go right to the reference tables. We go to the bottom, prefixes for powers of 10. Centi has the symbol C, and its notation is 10 to the negative second. Now remember what that means is that means that this is the number of base units in 1 centi something. So since we're talking about centigrams, I'm going to write 1 cg, open up my parentheses. Remember that I want to place cg where it will cancel out. This cg you can think of as really being like on the top of a fraction, like 1 cg over 1. Which means if we want to cancel out of cg, centigrams, and get into grams, cg has to go on the bottom here, which means it has to go on the top up here. Now we just need to fill in the correct numbers. Remember again that the whole point of writing it like this with this fraction is that the two numbers on either side of the fraction, the top and the bottom, numerator and denominator, should be equal measurements, but just in different units. So in other words, we want equivalent amounts here and here. Not equivalent numbers, but equivalent amounts given the unit. Again, since centi is 10 to the negative second, what that means is that's going to go up top. That is where 10 to the negative second grams is equal to 1 centigram. Now we just do the math. We know that centigrams will cancel out, so we do 1 times 10 raised to the negative second divided by 1 gives us 0.01 grams is equal to 1 centigram. Now, some of you might be saying, wait a sec, the whole deal with the negative exponent, that just seems like way too much work. I will show you another way you could do this, okay? It's still the same format, but just a different way of thinking about it. You could have also done something like this. 1 cg. Remember that we wrote on the front, to find how many prefix units are in 1 base unit, you switch the sign on the notation. So, centi is 10 to the negative second. That tells us that there are 10 to the negative second grams in 1 centigram. If we want to know how many centigrams are in a gram, we just make this positive. That would mean that there are 10 to the second centigrams in 1 gram. That would look like this. 10 to the second centigrams in 1 gram. Cg still cancels out. Notice that the format is still the same. We still have Cg on the bottom, grams up top. We've just changed where the numbers go. And again, think about it. 1 gram, 10 to the second, or 100 centigrams, those are equivalent amounts of mass. 1 times 1 divided by 10 raised to the second gives us, once again, 0.01 grams. So I'm just going to make a little note. If you have to deal with negative exponents and you don't like negative exponents, like most people don't, consider how many prefix units are in 1 base unit. In other words, negate the sign. Okay? You don't have to do that. It's just an option. I want to just point that out, that that is possible to do. Let's move on. Convert 4 megaseconds to seconds. Mega on our chart has capital M, and it's 10 to the 6th, or million. So 4 ms. We want to cancel out of megaseconds and get into seconds. Megaseconds is out here, so that means it's going to go on the bottom, and seconds goes on top. 1 megasecond, according to the chart, is 10 to the 6th seconds. So I simply do 4 times 10 raised to the 6th divided by 1 gives me 4 million seconds. There we go. Last one for this little group, 3.3 kilometers into meters. 3.3 km. Again, I encourage you, set up the units before you do anything else. So get the right places for kilometers and meters. Kilo means 10 to the third. So 1 kilometer is 10 to the third meters. 3.3 times 10 raised to the third is 3,300, or you could write 3.3 times 10 to the third meters. Not necessary to put in scientific notation, but usually it saves you a little bit of writing. Okay. All right. So moving on, sometimes a conversion can take more than one step. This usually happens when you don't quite know what the direct conversion is from one unit to another, but you do know different conversions that can be combined to get to the answer. We already did a combination problem like this, okay? This is a conversion that takes more than one step. And this was probably a little bit more familiar to you since we're used to dealing with time periods. We can do the same thing with mass or distance. Number 4 says how many centimeters are in a kilometer. So the number we're given right now is a kilometer. We want to convert that to centimeters. So I'm going to write down 1 km. And the first thing I'm going to do, since I don't know the direct conversion from kilometer to centimeter, I'm going to use something I do know. I'm going to convert from kilometers to meters. You might be thinking, well, wait, we have this nice chart. Why can't we just use this? Remember that all the notation on here is in reference to how big or how many base units there are if you use a prefix, okay? So, for instance, kilometer, the 10 to the third, is comparing kilometers to meters. First thing I'm going to do is convert kilometers to meters. Since kilo has the notation 10 to the third, that tells us there's 10 to the third meters in 1 kilometer. Which means, let's see, 10 to the third is 10 times 10 times 10, which is 1,000. Kilometers cancels out. That's 1,000 meters. We want to convert this to centimeters. Now, here's one where I won't actually use the chart when you're thinking about centimeters. Centi is 10 to the negative second, but let's think realistically here, okay? You need to know how many centimeters are in a meter. We use meter sticks all the time in this class, and maybe you're not used to it yet, but you need to know this. You need to know that in 1 meter stick, something with a length of 1 meter, there are 100 centimeters. That's also easy to remember. How many cents are there in a dollar? 100. 100 cents in a dollar, 100 centimeters in a meter. So when we convert from meters to centimeters, meters is going to go on the bottom, centimeters pops up top, 1 meter, 100 centimeters. Now let's talk real quick. What if you got that mixed up? What if you wrote 100 meters and 1 centimeter? Notice that that wouldn't make sense because 1 centimeter is like the width of a nail, of a fingernail, whereas 100 meters is like the length of a football field. So very clearly, if you had written 1 centimeter and 100 meters, those are two totally different distances, okay, two totally different lengths. On the other hand, 100 centimeters is exactly equal to 1 meter. The numbers aren't the same, but the fact that the units aren't the same makes that not matter. It's the same amount of length. Also notice one more thing, that the smaller unit, the centimeter, if you're doing a unit conversion, the smaller unit always has the bigger number next to it. The bigger unit has the smaller number. And that makes sense because we are trying to write equivalent amounts on top and bottom. Anyways, meters cancels out with meters. We're left in centimeters. So I have 1,000 times 100 equals 100,000 centimeters. There we go. We could do the reverse problem. How many kilometers are in a centimeter? This time we're going to start off in centimeters. 1 centimeter. And you'll notice here that I kind of used like this intermediate calculation. This time I'm not going to do that. I'm going to chain them all together like I did down here. We know that there are, from the last example, 100 centimeters in 1 meter. And we also know that there are 1,000 meters in 1 kilometer. So notice you can write it as 10 to the third meters. If it's 10 to the third or lower, I usually just like writing the number out. Just makes it easier for me to think about it. So we know that there's 1,000 meters in 1 kilometer. Meters cancel out. This time, we're going to do 1 times 1 over 100 times 1 over 1,000. But multiplying something by 1 over 100 is the same as just dividing by 100. I mean, I can prove it to you. 1 times, in parentheses, 1 over 100 gives us 0.01. Instead, I could just do 1 divided by 100, 0.01. So 1 divided by 100 divided by 1,000 gives us 0.00001 kilometers. In other words, a centimeter is a tiny fraction of a kilometer. I mean, we probably expected that, but still, good to see. Last one for this little chunk. How many milligrams are in 0.7 gigagrams? 0.7 gigagrams is how we're going to start off. Remember, giga is 10 to the 9th. It means a billion. There are 1 billion grams in 1 gigagram. Capital G. 10 to the 9th. So again, GM goes down here to cancel out. Grams, not M. Remember, grams is G. Can't read that. There we go. Okay, so 1 gigagram is 10 to the 9th. Gigagrams will cancel out. And we want to convert to milligrams. So now we have grams down here, milligrams up here. Milli means 10 to the negative third, which means there's 10 to the negative third grams in 1 milligram. But I gave you a trick. I said, you can do it if you want. You can do that if you want to deal with negative exponents. But the way I prefer to think about it is if you have a negative exponent, then make it positive, and then you're looking at how many of the prefix units are in 1 base unit. So since milli is 10 to the negative third, watch what happens if I do this. I'm going to write instead that in 1 gram, there's 10 to the third milligrams. Now I could have written 10 to the negative third grams is 1 milligram, but I don't like to deal with those negative exponents. If you don't like that, that's fine. Okay, if you want to just read right from the chart, that's absolutely fine. But I know some people don't like negative exponents. If you have to use a negative exponent, consider using the positive version of that exponent and just switching how you think about it. That would be how many of the prefix unit, milligrams, there are in the base unit, grams. You'll get the exact same answer either way, as long as you don't flip-flop these. Okay, that would be wrong if you did 10 to the third or 1,000 grams is 1 milligram. Those are not the same amount. So 0.7 times 10 raised to the 9th times 10 raised to the 3rd gives us 7 times 10 to the 11th milligrams. And that makes sense. We should expect a very large number because a gigagram is huge. Milligrams are very small. Okay, and notice that you don't have to do this intermediate step. You can do all of your calculations at once. Moving down to question number 9. Here we're going to be going and converting from what we would call imperial units to metric units. If 1 inch is 2.54 centimeters, how many meters are there in 1 yard? You should remember this part of the notes for the homework, okay? Specifically this conversion right here in the notes, because that's a conversion that you will have to use. On a test or quiz, I will always give that to you. It's not something you need to memorize, but on the notes, you should know this, okay? You should, or not know this, but you should be able to look this up in your on your homework using your notes. This conversion, by the way, is very common. I remember it being printed on rulers when I was a kid in like elementary school, and I've remembered it from there. 1 inch is 2.54 centimeters. This is a bridge between what we would call imperial units of measurement, what we use in America, the United States of America, and the metric system, what they use in the rest of the world, and what we use in science. How many meters are there in 1 yard? You might be tempted to say they're about the same thing. And they are about the same thing, but they're not exactly the same thing. Okay? So we need to figure out exactly how many meters there are in 1 yard. Which means we're going to start with 1 yard. And our goal here is to figure out how many meters. So we need to convert from yards to meters. I don't know the exact conversion. If we did, we wouldn't have this problem. But I do know how many feet are in a yard. And even better than that, I know how many inches are in a yard from the front page of this notes. I know that there's 36 inches in 1 yard because there's 3 feet in a yard. So I'm going to use a conversion to inches first. I'm going to write 1 yard, down the bottom to cancel out, is equal to 36 inches. That'll put me in inches. Now I can use my conversion. 1 inch is 2.54 centimeters. Cancel out of inches. If I were to stop there, I would have how many inches are in centimeters are in 1 yard, but I want meters. So to go from centimeters to meters, I know that there's 100 centimeters in 1 meter. The math here works like this. I have 1 times 36 over 1 times 2.54 centimeters over 1 Oops, let me cancel out the centimeters. Not that it really matters. Okay, 1 times 36 over 1 times 2.54 over 1 times 1 over 100. What that works out to is 1 times 36 times 2.54 divided by 100. 1 yard is equal to 0.9144 meters. In other words, a yard isn't quite a full meter. A yard is about 36 inches. A meter is approximately, give or take, I'm blanking here. A meter is about 39 inches. Here's another conversion to remember in number 10. A good one. That's why I include it in your notes. Again, I would give it to you on a quiz or test. However, it's a good one to remember. If 1 kilogram is 2.2 pounds, convert 500 ounces into kilograms. We're going to start off with 500 ounces. I know from the front, if you look at the front, that there are, okay, so my strategy here, let's convert from ounces to pounds, and then I can convert from pounds to kilograms. I know how many ounces are in a pound, 16 ounces in 1 pound, and I know how many pounds are in a kilogram, 2.2 pounds, 1 kilogram. So the work here is to take 500, divide by 16, divide by 2.2, and I end up with 14.205 kilograms is equal to 500 ounces. Again, the numbers are not really the important part here. What I need you to understand right now is the process that we're using, the thought process. We start with some number. We use certain conversions that we either know or can look up. We make sure to set up our conversions correctly so that the old units will cancel out and we'll get into new units. And then we make sure to do the math properly. Doing the math properly is the last step, okay? That's the final step. There's like 3 other things to check before we get there. The last 2 examples that we're going to do involve compound units, such as the units for speed. Think about when you're driving. Some of you might have your license already. You're driving on the highway or just on any road, and you see a speed limit sign. Okay, you see a 40 up there. What does that mean? 40 what? Probably 40 miles per hour, okay? That's a unit of speed. Anytime you take a unit of length, such as a mile, and divide by a unit of time, like an hour, those are units of speed, okay? 40 miles per hour is a speed. In physics, we typically use the units of meters per second. We can write this a number of ways. So you can write out meters/seconds. You can just do m/s. Or the one that you'll see me use most is m and then over the top of s. I use this the most because it's just easier to write that way. Some other units of speed that you might be familiar with, like I mentioned before, miles per hour. If you go up to Canada, you'll see kilometers per hour. Occasionally, you might see, if something's moving really fast, like kilometers per second. All of those are different units of speed. Converting, when we have these compound units, isn't necessarily any harder. It just takes a few more conversion steps here. You have to use more conversion factors. Okay, so convert 20 kilometers per minute to meters per second. So we're going to start off with 20 km over min. You're going to convert one at a time. Okay, so you can, and the order doesn't matter. You can either convert the kilometers first or you can convert the minutes first. Let's do the minutes first because that one's more familiar to us. We want to get from kilometers per minute into meters per second. So we need to convert from minutes to seconds. Since minutes is on the bottom, think about it. Would it make sense for me to put minutes on the bottom in my conversion? No, because then if we multiplied, I just have minutes times minutes, which is like minutes squared. That doesn't make sense. What if I put minutes up here, on the other hand? If I have minutes on the bottom and minutes up, and I'm multiplying by something with minutes on the top, they will cancel. So notice that when you're trying to do unit conversion, you don't always put the unit you're canceling out of on the bottom. We did that here all the time because we just had nice, easy units to use. Here, we have to put minutes on top because it appears on the bottom in our original number. So the placement of the units you're trying to cancel out, it really depends on where they appear in your original number. Seconds is going to go on the bottom this time. We know that there's 60 seconds in 1 minute. If I were to stop right now, I would have an answer in kilometers per second, but I want meters per second. So I'm going to leave my minutes conversion. Now I'm going to convert kilometers to meters. Since kilometers is up here on the top of the fraction in the beginning, it's got to cancel out so that we're left with meters up top. Meters is going to go on the top, kilometers is going to go on the bottom so that it cancels. Using my chart, I know that kilo means 10 to the third, which means since a kilometer is very big, it takes 10 to the third meters to equal 1 kilometer. 10 to the third, as we've done before, is 1,000. So this time I will do 20 divided by 60 times 1,000, and I get this, 333.3 meters per second. Let's see if the answer makes sense. 20 kilometers per minute. 20 kilometers is a long way. It's like 14-ish miles. So that's like saying going from like here to like, I don't know, Barneveld in 1 second. Yeah, that's really, in 1 minute. That's really, really fast. That trip usually takes about 20, 25 minutes. So it makes sense that your number of meters per second would be very high. This is like going basically 1 kilometer every about every 3 or so seconds. And remember, a kilometer is pretty big. It's not quite the same size as a mile. It's about like about 6/10 of a mile, but it's still quite a big distance. Okay, so this answer seems to make sense. Last one, the highway speed limit in New York State is typically about 65 miles per hour. How fast is this in meters per second? Okay, how many meters per second is the average car following the speed limit going on the highway in New York? So we're going to start off with 65 miles per hour. We can convert miles first, or we can convert hours first. I'm going to show you a little trick for hours. It's actually pretty easy to remember, if you don't already, how many seconds are in an hour, since we're trying to go from miles per hour to meters per second. In 1 hour, there are 60 minutes, and in each minute, there are 60 seconds. If you just remember, 60 times 60 is 3,600, or 3,600 seconds. That's the conversion from hours to seconds. 1 hour is 3,600 seconds. The conversion from miles to meters is going to take a lot more. There's not an easy conversion from miles to meters, or at least there isn't one that I have off the top of my head. I do, however, from the front, remember that there is a certain number of feet in a mile. I remember that in 1 mile, oh, by the way, notice that hours was on the bottom in our original number, which means to cancel out, we had to go up top up here. Miles is on the top in our original number, which means it has to go on the bottom down here. In 1 mile, there is 5,280 feet. That would put me in feet per second, but that's not what I want. I know how many inches are in a foot. Put feet on the bottom, inches up here, 12 inches in 1 foot. This might seem to you like we're kind of not going anywhere, but notice that miles is an imperial unit, meters is a metric unit. We need some way to convert from imperial to metric, and that way is listed right up here in problem number 9. 1 inch is 2.54 centimeters. That's why I converted to inches first. 1 inch, 2.54 centimeters. Now, it's very easy to convert from centimeters to meters. And I'm left with units of meters on the top, units of seconds on the bottom. The math here would be 65 divided by 3,600 times 5,280 times 12 times 2.54 divided by 100. And we get that 65 miles per hour is equivalent to 29.06 meters per second. So a car traveling 65 miles per hour, going from here to like just about the other side of Syracuse in 1 hour, is traveling just under 30 meters per second. So think about it, my classroom is about 10 meters long. At highway speeds, a car is traveling 3 classroom lengths in 1 second. That's very, very fast. As always, if you have any questions with unit conversion, the process that we're doing, please don't hesitate to ask in class or electronically. This is a pretty crucial skill because you're going to have to do at least a few unit conversions for each unit as we go through the year. It is also something that's tested on the Regents. There's almost always one question just on unit conversions. It's not particularly hard. The math is no more difficult than just multiplying and using maybe some exponents, but it is important that you understand how it works right now. Next time we talk, we're going to be talking about measurement error and uncertainty, and I'll have another video for you for that. Talk to you later.